Hello friends, in the last videos you have seen that consolidation settlement can be calculated using coefficient of volume compressibility MV. Now we would like to see how to make use of compression index, recompression index if it is over consolidated clay, and under what situation it should be used. All those things I will explain with the help of one problem. So we are going to take one example uh, for over-consolidated or pre-consolidated clay. For normally consolidated clay, we have prepared one video for calculating the consolidation settlement using compression index. So in today's example, let's say this is the ground situation. At the ground level, you have got up to 2 meters from ground level. You have sandy deposits. So this is the sandy deposits, and the groundwater table is going to touch the ground level. And below this, let's say up to 5-meter depth, it is clay soil bed, and then followed by sandy deposits. The unit weight of the sand, the saturated unit weight, is 20 kilonewton per cubic meter. And the saturated unit weight of the clay is also 20 kilonewton per cubic meter. The value of from one-dimensional consolidation test, you have found out the value of Cc, and you also know the value of recompression index Cr. The value of Cc is 0.3 and the value of recompression index is 0.03, 10% of this value. And the initial void ratio E naught is 0.75. So these are the informations. Now, you are going to have a footing. A column comes and you are going to have a footing over here. So this is the footing, the square footing. This is the column which transmits a load of 400 kilonewton. The size of the footing, square footing, is 2 meter by 2 meter. So the area of the footing is 4 square meter. So this is the situation. So what is the intensity of loading at the base of the footing? Q is going to be 100 kilopascal. 400 divided by 4, so it is going to be 100 kilopascal. Now, we need to calculate the consolidation settlement of this footing. Deliberately, I have taken this problem where we will be making use of CC, CR, etc. because this topic is very, very important from GATE and other competitive examinations where consolidation chapter gets prominence. So, in the theory, I've already explained to you the concept of consolidation. Now, here you need to calculate the consolidation settlement. So, how will you do this? The very first thing is that what is the thickness of this clay layer? Calculate the thickness of the clay layer. If you see, it is from 2 meter down 5 meter. So 5 minus 2, 3 meter is the total thickness of the clay layer. Now, in order to calculate the consolidation settlement SC, we should divide this clay layer into 3 parts. So, as per codal provision, I am going to divide the H into 3 parts. So, you will have H1 equal to H2 equal to H3 equal to 1 meter. Therefore, H1 plus H2 plus H3 equal to 3 meter. Now, if I take the layer 1, let's say this is my layer 1, this is the first layer of thickness H1, this is the second layer of thickness H2, and this is the third layer of clay H3. So there are 3 layers. So let's take layer 1. For layer 1, as you know, you will have to calculate at the midpoint of the layer 1, calculate the effective overburden pressure. So, the effective overburden pressure for layer 1 will be equal to, this is going to be 2 meter, and at the midpoint, the effective overburden pressure, that is going to be H1 1 meter. So, it is going to be 0.5 meter below this. So, total depth from ground level up to point A, which is the midpoint of layer 1, is 2.5. So, 2.5 meter multiplied by the saturated unit weight is 20 minus 9.81 will give you the effective overburden pressure. So this you can calculate in kilopascal. Now at the midpoint, because you know that the load is going to spread like this. The load will spread at 2 vertical and 1 horizontal. Therefore, the increase in pressure, the average increase in effective pressure due to the application of the load is called delta sigma 1 prime, equal to the intensity of loading multiplied by area of the footing divided by B plus, at the midpoint it is H1 by 2, so it is zero point 0.5, so 0.5 by 2 on the left hand side, 2 vertical, 1 horizontal, and on the right side. So it becomes B plus 0.5. Midpoint is at 0.5 of layer 1. So you add that and whole square. So if you can calculate this, and this will be also in kilopascal. And then you should calculate sigma naught prime for layer 1 plus delta sigma 1 prime. You can calculate it in kilopascal. So let us take our calculator and you can calculate this. Quite simple. This becomes 10.19 multiplied by 2.5, 25.475. And this one is 400 divided by 2.5 square is 64. Therefore, the sum of these two, 64 plus 25, equal to 89.475 kilopascal. Now, from the test, one-dimensional test, it is given in the problem, in this example, that the pre-consolidation pressure is 50 kilopascal. This is given in the example. So you carry out the collect the sample and you have carry out the 1D test. Third, that has shown that the pre-consolidation pressure. In the previous videos, I have explained to you how to find out the pre-consolidation pressure. So what it shows? It shows that the effective overburden pressure is less than. Therefore, it shows that effective overburden pressure is less than pre-consolidation pressure. But pre-consolidation pressure is less than sigma naught 1 prime plus delta sigma 1 prime, which is 89.475. That means sigma naught 1 prime is less than this, but sigma naught 1 prime plus delta sigma 1 prime is greater than pre-consolidation pressure, which is 50 kilopascal, whereas you get it 89. Here you got it 25, but PC is 50 kilopascal. So this is the situation. So the soil is going to behave like over-consolidated or pre-consolidated clay up to 50 kilopascal. So when you are going to have log sigma prime here, and it is going to behave the and like this. There is the pre-consolidation pressure. And this pre-consolidation pressure is 50 kilopascal, whereas my effective overburden pressure is uh, only 25, somewhere here. This is my sigma naught prime for layer 1. So it is going to behave. If this is the situation, then from this 25.475 up to 50, the consolidation settlement needs to be calculated as pre-consolidated clay, over-consolidated clay. And therefore, the formula to be used for this situation will be like this. So, SC now of layer 1 will be, now from here to here, it will behave as a pre-consolidated clay. So you should take recompression index divided by 1 plus E naught into H1 into log of sigma naught prime for layer 1. This is the lower value. The higher value should be taken here. So here the higher value is PC. So PC divided by sigma naught prime for layer 1. So this one to the base 10 plus. For the remaining part from 50 up to 89.475 kilopascal, it is going to behave like normally consolidated clay. So this is going to behave like NC clay, and this is going to behave like OC clay. So now for normally consolidated clay, it is going to be compression index Cc divided by 1 plus E naught into H1 into log of. Now, what is the greater pressure is 89 point this. So sigma naught prime for layer 1 plus delta sigma 1 prime upon, this is going to be lower pressure, that is PC. So this becomes the formula. Very simple to remember. From textbook, normally you do not get this point, higher pressure to lower pressure. But this graph is self-explanatory. So deliberately I have drawn this to make this point crystal clear, that how you are going to take the higher pressure and lower pressure, higher pressure and lower pressure. Now, the value of CR, therefore SC1, the consolidation settlement of layer 1, therefore will be equal to CR, which is 0.03, and E naught is 0.75, so it becomes 1.75. H1 is 1 meter into log of PC is 50 given, divided by sigma naught prime for layer 1 is 25.475 plus CC is 0.3 divided by 1.75 into 1 into log of sigma naught prime plus delta sigma 1 prime is 89.475 divided by 50 to the base 10. I hope this point is clear to you. Unless you understand this, you can't solve the problem. So let's simplify and calculate the value of SC1. I will be able to do it quickly. Calculation, all of you are very comfortable, so all of you can do it without any problem. So log So I hope that you understand, and this gives you 0.048 meter. SC1 is known to us. We have very easily calculated the value of SC1. So SC1. Now go to the layer 2 now. So layer 2, if you go, similar way we can calculate. So let's go to layer 2 now. Going to layer 2, I need to calculate the value of sigma naught prime for the layer 2, which will be, now if you go to the layer 2, at the midpoint, the average value is going to be 1.5 plus 2 meter. So 2 meter of sand, 1 meter of clay layer and 0.5 meter of the second layer. So 1.5 plus 2, 3.5. So this becomes 3.5, and if you calculate it, 3.5 into 10.19, you get 35.665. 35.665. So this is the value of sigma naught 2 prime. Now the load is going to spread to vertical, one horizontal. Therefore, you should calculate here the increase in pressure due to the loading, that is called sigma naught prime at the midpoint of the layer 2 will be how much? It is going to be 1 meter, and this is going to be 0.5 meter. So 1.5 plus 2. So this becomes 3.5. So here we are going to have the midpoint is going to be 3.5 whole square. So 400 divided by, if you calculate it, this gives you 32.65. Therefore, this becomes, this for layer 2 plus delta sigma 2 is going to be 68.31. Now, your sigma naught 2 prime is 35, is less than PC. Okay. But the sum of these two is greater than PC, the pre-consolidation pressure. So this plus this, as we have calculated here, is 68, which is more than 50. So it is more than 50. Therefore, for SC2, the formula will be this. Now this is okay. This is okay. PC is okay. But here, the sigma naught 2 prime has been calculated as 35. So this you change it, 35.66. Now, here the sum total of this has to be changed, which is 68.31 divided by 50. Therefore, we can calculate SC2. So SC2 from this simplification of this will give you log of 50 divided by 35.66 multiplied by 0.03 divided by 1.75 plus here log of 68.31 divided by 50 into 0.3 divided by 1.75. This is going to be 0.025 meter. Now, what is the third layer? Third layer is going to be also 1 meter. So let's go to now layer 3 and calculate sigma 3. So at the midpoint of this layer 3, what is this height? 1 meter, 1 meter, 2 meter. So 2.5 plus 2, 4.5. So this becomes 4.5 into this. So 4.5, let us calculate 4.5 multiplied by 10.19 gives you 45.855. 45.85 kilopascal. Similarly, the increase in pressure due to intensity of loading through the footing will be this. So what is the area at this midpoint? It will be 2 meter and now it is going to be 2.5. So 2 plus 2 becomes 4.5 whole square. So this becomes 400 divided by 4.5 square, 19.75. So this becomes 19.75 kilopascal. Now, therefore, the sum will be 65.60. So this becomes 65.60. This is again satisfies this condition that sigma naught 3 is less than PC and sigma naught 3 plus delta sigma 3 is greater than PC. Therefore, this formula you will have to use it. Now H2, replace it by H3. This you replace it by this one. This you replace it by 3 by PC. So you can calculate now SC3. So SC3 will be 0.03 divided by 1.75 into 1 log 50 divided by Sigma naught 3 you have calculated as 45.85. 45.85 plus this is okay, log of this is going to give you 65.6 divided by 50. So such a simple calculation we can now make it. So easily we can calculate now. So let us calculate log of 50 divided by 45.85. $65.6 divided by 50. .20. SC3 is 0.20. So 0.20208 up to 3 decimal places. 0. No, sorry. There's 0.020020. Okay, up to 3 decimal places plus 0.025 plus 0.48 equal to, this becomes SC equal to therefore 0.093. That is equal to 93 mm. So friends, today we have tried to make your concept clear that if it is pre-consolidated or normally consolidated combined effect, how to calculate. You see, you have got CR also, you have got CC also. How to calculate, how to attempt any problem. This will help you a great deal in solving any problem in the competitive examination, including GATE. Thank you very much.